Today's video, we're gonna talk about magnetrons, the principle and how it works. Say you wanted to cook a dinner in 5 minutes or make an airplane safer fly in bad weather. You'll be needing some microwaves then. Those are the invisible, super energetic, short wavelength radio waves that travel at the speed of light, doing important stuff in microwave oven and radar navigation equipment. Making microwaves is easy if you have the right equipment. A handy gadget called a magnetron. What is it and how does it work? Let's take a closer look. So what is a magnetron? A magnetron is an electric tube for amplifying or generating microwaves with the flow of electrons controlled by an external magnetic field. Magnetrons are diodes in which the electrons traveling to the anode are set in spiraling paths by the magnetic field created by permanent magnets. So, there are different types of magnetrons. The first one is the negative resistance type. Negative resistance magnetrons make use of negative resistance between two anode segments. They have low efficiency. They are used at low frequencies, less than 500 megahertz. The next is cyclotron frequency type. Cyclotron frequency magnetrons depends upon synchronism amid an alternating component of electric field and periodic oscillation of electrons in a direction parallel to this field. The synchronism between the electric component and oscillating electrons is considered. It is useful for frequencies higher than 100 MHz. Then wave or cavity type. Cavity type magnetrons depends upon the interface of electrons with a rotating electromagnetic field of constant angular velocity. The interaction between electrons and rotating EM field is taken into account. High peak power oscillations are provided. This is useful in radar applications. Applications for magnetrons include radar, microwave ovens, and lighting systems. In radar devices, magnetrons use very short pulses of applied voltage. In microwave ovens, a waveguide leads to a port in the cooking chamber. In lighting systems, in such as sulfur lamps and metal halide lamps, magnetrons also produce a microwave field.
How does a magnetron work? Electrons are emitted from the center cathode and also magnetic field through the cavity. Electrons will follow a spiral pattern going outward. Electrons cycle around in a spiral pattern called the cyclotron. When the electrons reach the end of the block, the outside wall of the magnetron cavity, they will induce a charge separation of voltage across the anode resonating cavities. Of course, across the resonating cavity, the capacitor creates a constant electric field across. Then the one-turn inductor will create a magnetic field in and out of the circle. And also, and of course, electric field and electromagnetic field magnetron are perpendicular to each other. In between the rod and the ring, the red lines you see here are the electric field created inside the magnetron. Considering an electron interacting with the fields causes to slow down and use energy, and called retorting the electron, and absorb in the RF that is being created by the resonating cavities. Magnetron consists of two permanent magnets flanking the copper ring. There's a copper rod in the middle between the ring and the rod is a vacuum. Copper rod is a cathode, or negatively charged electrode. Copper ring electric field exists between the two electrodes. Negatively charged electrons run through it. Magnetic field created between two electrons moves from the filament to the copper ring called the Lorentz force. This causes electrons to spiral as they leave the filament and ended up as a pinwheel. The end consists of a pure concentrated negative charges.
Hi, I will discuss how a magnetron is constructed. A magnetron is a high-power microwave oscillator which is used to produce oscillations of very high power. Its working principle is based on the interaction between electron stream and magnetic field. It works on direct current power which can be used for radars, heating such as microwave ovens, and lighting such as sulfur lamps. The combination of the small cavity magnetron, small antennas, and high resolution allowed small, high-quality radars to be installed in an aircraft. It was invented by Randall and Booth. This figure shows the constructional details of a cavity magnetron. I'll discuss each detail more specifically. In this figure, you'll see that the magnetron consists of an anode block made of copper or brass. It is in the cylindrical shape through which the even number of cavities of the same size towards the external circumference is made at the center of the anode block. There is a hole which the cathode is located. The center hole of the anode block is connected with each of the cavity by slap coupling. The output of the magnetron is taken with the help of loop coupling. Around the anode block, there is a strong permanent magnet across the cathode with opposite ends. Depending upon the relative strength of the magnetic and electric field, the electrons released from the cavity move towards the anode will navigate through the interacting space. Though the magnetron is a fairly effective device, the frequency is not precisely controllable. Additionally, they are costly and has limited use.
Advantages of magnetron. Magnetron are capable of developing extremely high levels of microwave power, thousands and millions of watts. It is a fairly efficient device. The combination of small cavity magnetron, small antennas, and high resolution allowed small and high-quality radars to be installed in aircraft. Disadvantages of magnetron. Magnetrons are costly and hence limited in use. Although it is used because they generate a wide range of frequencies, the frequency is not precisely controllable. Electrical hazard due to high voltage power supply. Have beryllium oxide ceramic insulators which are dangerous if crushed and inhaled.
So that wraps up our video for today. Thank you for watching and see you guys next time. Peace.